Winnie, you might start.
All right. Good afternoon, everyone, and welcome to the very interesting session today. Today, we have a session titled "The Use of Big Data to Predict Economic Activity During COVID-19 Pandemic." And I would say that this is a very interesting session because, as you know, that during the COVID-19 pandemic, that we need innovative data and also real-time data, and we cannot only rely from statistical data. So there is like a lot of opportunities we can utilize big data to predict any economic activity during COVID-19 pandemic. So in this session, we will have three presenters with three papers, and all the papers are very interesting to be listened to. Now, the three papers are, we will have the first paper titled People's Mobility and Economics During COVID-19. And the second one is the use of mobile phone data and economic inequality before and after COVID-19. And the last paper will be titled The Use Night Lights to Predict the Economy. We will also have a discussion here. Gemma van Haldern, Australian Bureau of Statistics. And she will discuss and tell about the use of big data to predict economic activity during COVID-19, and a lot of inputs and suggestions on what during COVID-19. This paper will be presented by Sylvia Arini and Rendra. They are actually working for Statistics Indonesia. And I would like to invite Sylvia, Arini, and Rendra to give presentation for about maximum 15 minutes. And I'll offer the floor to you.
Okay, thank you so much for the times. Hello, good morning, everyone. Thank you so much for the okay, can you see my screen now?
Yes, it's already shown.
In these sessions, I will present about the measuring the economic activity during COVID-19 pandemic and evidence of people mobility data toward economic activities. This paper is a group work with my colleague Rendra Ahyunda Anupraputra. Okay, in these sessions, I will discuss, this is the outline. The first is introductions, following with data, methodology, discussion, and conclusions. For the backgrounds of this paper is, the WHO has been declared COVID-19 as a pandemic on March 2020. In this situation, there is increased need of high quality and real-time data in crisis times. And to reduce the virus spread, Indonesia imposed social restrictions. So some survey activities could not be conducted. And of course, it will affect the publication of some statistics. In addition, we also need to modernize the data life cycles of compilations, productions, and dissemination to make it robust to shock, including the pandemics. The contribution of this study the first one is the study combined traditional and non-traditional data sources, including big data on mobility and GDP data. And then this study also measure economic activities under social restrictions, which lead to delay on data collections, as well as utilizing big data as new data sources, which more reliable in presence of disruptions, including social activities restrictions. This study used several of data, and the study combined traditional and non-traditional data. For the traditional data, we use official statistics such as regional GDP and GDP. For non-traditional data, we use mobility. In this case, we use People Mobility Index. Mobility Index is the index which shows the movement trends produced by the people. And the study also used nighttime light data. Okay, I will discuss about the methodology for this study. The methodology for the study is consists of 4 steps. The first one is clustering its regions. The study cluster its regions, in our cases is province in Indonesia, based on industry contribution to regional GDP. And then we also we calculate the people mobility change. We calculate based on the People Mobility Index. After we cut the cluster from the first step and the people mobility change from the second step, we use it to estimate the regional GDP growth for the third step. We use those calculations using, we implement equation interactions between regional GDP, mobility, and cluster. And then for the first step is we estimate the GDP change. After we got the estimated regional GDP growth from the previous steps, we use it to calculate the estimated national GDP. Okay, we can move to the discussions. For the discussions in here, like this is the description of the relationship between mobility and the economic activity. In a daily basis, every day, people mobile to do their activities, including economic activities. From this mobility and these activities provide output in terms of economics. And this output can be used to calculate the economic growth. Before the pandemics, people have a normal mobility and the pattern is used as a baseline. And in this period, also the economic activity of shock. During the pandemics, governments impose social activities restrictions, so it lead to the less economic activities because of less mobility. And also in this period during the pandemic, there is a behavioral change, example work from home. If you can see from this heat map, in the beginning of 2020, the heat map showed the red color, which represents of high mobility because it's still the normal mobility pattern. And after the social restriction in here, there is the heat map show the green color, which represents the lower mobility of the people. And then social restriction policy has changed people mobility behavior in Indonesia. From this graph, we can see that the activities increase in place of residence. We can see in the blue lines. And while in the other place, such as grocery, workplace, park, retail and recreations, transit stations, the activity is decreasing. And Indonesia starts social restrictions since March 2020. This is the start of Indonesia, the social restriction in Indonesia. And if you can see, in Q2, the decreasing of people mobility is quicker than in Q1.
Oke punya.
This study implements clusterings. The motivations why we implement clusterings is because each region's province in Indonesia has different industry contribution to regional GDP. However, mobility change affect each industry differently. Industries that closely related to mobility, such as transportation and trade, will suffer more because of the lower mobility. On the other hand, some industries that are not too affected by the mobility, for example, mining and quarrying, are still operated during the pandemics, but with lower capacity. Therefore, we implement clustering to minimize bias due to mobility change effects on the industry. We compare model with and without the clustering. The outcome from the model, which involved the clustering, it showed that it can increase the explanatory power of mobility for regional GDP. And the model, which involves the clusterings, also provide better fit model to estimate the regional and national GDP. For the regression model, the study showed that the mobility significantly affects regional GDP. However, the magnitude of the mobility impact to regional GDP differ across cluster. As you can see from these graphs, the slope of each lines is differ among the cluster sector. Okay, then. After we got the estimated regional GDP, we estimate the national GDP. Based on our calculations, in the 2020 quarter ones, the official GDP show that
Iya kali.
the growth is
Nggak ngerti deh.
3%, while our estimated growth GDP is 2.6%. And for the 2020 quarter two,
Nggak tahu
the
aku.
official GDP growth is minus 5.4%, while our estimated GDP growth is minus 5.2%. Okay. From this study, we can conclude some points. The first one, in terms of clusterings, the study showed that each region is clustered based on the industry contribution to regional GDP to adjust the effect of mobility to the industries. And in terms of mobility and regional GDP, the study shows consistently strong positive correlation between regional change of the average mobility and the percentage change of regional GDP. And in terms of the GDP itself, it shows that the estimated GDP and the official GDP growth are close. Okay, that's the discussions for this paper. Thank you for the attention. I will come back to time.
Ini Kak, si Rendra sama Sylvie itu suami istri.
Thank you, Sylvia, for the very nice and also very insightful presentation using the Google Mobility Index and also nighttime lights index, and you can have something to predict how the GDP, including the regional GDP, to change due to due to what you call it, restrictions that happen during the COVID-19 pandemic. And also I think we can apply this model that you develop to predict the GDP as well in Q2 and Q3 2021. As you know that Indonesia is now again implementing the mobility restriction, especially in this year, started in the end of June, 2021. I think we started the PPKM since the 3rd of July 2021, right? So I think this could be one of the potential model that we can use to predict GDP of Indonesia in second quarter and also in the third quarter, to see how the restriction will affect the GDP of Indonesia, including the GDP of provinces, of some provinces in Indonesia, especially Java and Bali provinces, that we really implement a very strict very strict mobility restriction, or we call it PPKM. Thank you, Sylvia, for the presentation, and I would like now to proceed with the second presenter. The title of the presentation will be the use of mobile phone data and economic inequality before and after COVID-19. This paper will be presented by Hani Wulandari and Amanda. Amanda will be the first presenter, and also Hani and Amanda now is working for Statistics Indonesia. And the time is yours, Amanda.
Okay, thank you for the opportunity. First of all, let me introduce myself. My name is Amanda Pratama Putra. I'm a young statistician working for BPS, Statistics Indonesia. And now I'm going to present our research. This is a collaborative work from me and my partner, Ms. Henny Wulandari regarding the use of mobile positioning data as a proxy of economic activity in Indonesia. So this is the outline of my presentation. First, let me explain about the introduction of this study. As we know, COVID-19 is a global pandemic that strongly disrupted the economic activity in Indonesia because to prevent the spreading of the virus, our government issued a regulation about large-scale social restriction to limit the human mobility. On the other hand, to formulate immediate policies and strategic response to the pandemic situation, the government requires a new real-time data analysis for quick policymaking. Unfortunately, the conventional approach like interview survey to capture the economic situation have several limitations, especially in timeliness aspect. And based on this background, the study tried to experiment with a new approach using big data from mobile network operators, MNOs, called as mobile phone data or mobile positioning data, MPD. It is an alternative data source that can be used to capture the human mobility pattern in some specific areas reflected by the log data information of mobile network subscribers. As we know, human mobility pattern are linked with economic activity. That's why our study aimed to check whether the MPD can be a good proxy to capture the changes in the economic, especially regional economic activity in Indonesia during the pandemic. Hopefully, the study can support the production of official statistics, inspiring the community to start the initiative of big data exploration, and also can bring more faster information with good quality to the policymaker to help them creating a responsive and quick data-driven policy. This is the example of MPD. So we can see that there are movement or there are human mobility across the region. And based on this data, we try to proxy the economic activity in Indonesia. And next, for the references, there are some research related to this topic. MPD has been used in various contexts, such as tourism statistics, transportation system planning, and traffic monitoring and measurements. In BPS, to support the production of official statistics, my team already conduct a study regarding the use of MPD to estimate the commuter flows in metropolitan areas. And another important references that can be used for this research is from Adipova et al. In 2019 that explored the mobile phone data statistics as a proxy indicator for regional activity assessment in Latvia. Based on their research, they found that the economic activity of counties in Latvia can be estimated, and in the particular case, positive dynamics of regional development has been detected. For the data that we use in this study, there are two data. The first one is MPD. It is a large-scale location data from MNOs or from mobile networks operators. And this data is a sample data set collected from Telkomsel, the biggest MNO in Indonesia. We got 5% sample data set that proportionally distributed following the population distribution. And second, for the official statistics of economic indicator, we gather the quarterly gross regional domestic product, or we call it as GRDP, released by BPS during the period of first quarter and second quarter of 2020. So instead of growth, we use the actual GRDP value in a constant price. And now, if we talk about the methodological explanation, there are 5 steps in our study. The first step is to generate statistics of subscribers activity from MPD. The result is subscribers count by day and province. Second, we're grouping each province using cluster analysis based on daily pattern of subscribers count. Technically, we use a K-means method. It's very simple with silhouette index as validation metrics, and we find out that 2 cluster is the best result. I will explain more about this result on the next slide. Sorry. Okay, for the third step, we summarize the data from step 1 to get the median subscribers count aggregated by province and quartile. It will be used later in the regression model. And next, we modeling the data using linear regression model to predict GRDP using MPD with cluster interaction. And the last step, we evaluate the model to check the significance of the model and also to check the distribution of residual. And now I'm talking about the result and analysis. Okay, so this is the statistic from MPD that shows subscribers count in daily basis. In the left chart, is represent Indonesia. And as we know, large scale of social restriction in Indonesia start in mid-March 2020, when the first case confirmed in the early March. As the result, the subscribers activity detected fell by 20% in April 2020. And the right chart visualize daily subscriber in several provinces, including DKI Jakarta, the capital of Indonesia, represented by the red line. We can see that the decline in DKI Jakarta was steeper compared to the other province. There are also strong indication of weekly seasonality pattern from the data. And then we do a clustering analysis, as I mentioned in the methodological part. So we try to grouping the province into two clusters, namely cluster 1 and cluster 2. And this is the visualization of their daily activity. As we can see there, cluster 1 consists of province with higher subscribers activities on weekdays. And DKI Jakarta, as the capital of Indonesia, also part of this cluster. This can indicate that cluster 1 are province with higher economic activity compared to the cluster 2. This is the indication that cluster 1, because the cluster 1 have a higher subscribers activity in weekdays where people going to work to that location. On the other hand, the cluster 2 have a higher subscribers activity in the weekend. And now to measure the association between MPD and GRDP, we use a regression model with this kind of formula. The dependent variable is GRDP with log natural transformation, and the independent variable is median subscribers from MPD with its interaction to the dummy variable of our clustering. So the model summary shows that every coefficient of our regression are statistically significant. The coefficient determination of the model is 0.7976. It means that our model can explain a 79% variation of GRDP value. And based on the result and analysis, we come up into some conclusion. The first one is we can say that MPV is a good proxy in predicting the pattern of GRDP in Indonesia, especially when there are economic changes due to the change in the human mobility patterns, like in the COVID-19 pandemic situation. And also the province cluster, which represents the different patterns of daily activity, significantly affect the relationship between MPD and GRDP. So for future research, hopefully the study can rely on larger samples with larger sample size, because currently we only use 5% of samples that sets. And also we hope we can use more complex MPD characteristic. There are a lot of things that we can do with MPD, but in this case, we only, this is a starter kit. So we only use a very simple characteristic from MPD, and we don't expect the coefficient of determination can be this high. So hopefully for future research, we can have more complex characteristic of MPD, and also we can have a longer observation periods, and it will be useful for our next study. I think that's all the presentation from us. Thank you for all your attention, and terima kasih. Stay safe, stay at home. Thank you.
Thank you, Amanda, for the very interesting and insightful presentation. This shows us that there is another potential of using big data. And for this one, we can use mobile positioning data to predict the GRDP of Indonesia. I think if you compare with the first presentation that are using Google Mobility Index and nighttime light index data, probably there's like some advantages and disadvantages of using MPD. The disadvantages of using MPD is that the data is not available for free, right? But you know that Google Mobility Index and nighttime light data is available for free. But the thing is that the advantages of using MPD, that we can have more characteristics of the data that we can explore more, right? We can see the mobility or the characteristic of the data based on the gender, for example, or based on a specific area that we would like to look at. As you know that Statistics Indonesia also already use MPD very intensively for providing tourism statistics, of even it is now becoming official tourism statistics. So I think this is another potential that we can explore more. But again, this big data is very really what I will call it really benefit for all of us, because during the COVID-19 that we always would like to have a real-time data, not until waiting for the official data that will come only, about 3 months lags. But the thing is that using big data is very advantageous for us, because of it can be available in real time. So I think we can proceed now to the last presenter. The last presenter will be the title of the presentation will be the use night lights to predict the economy. And then this will be presented by Agung Andio Jaya and Nefriana from Statistics Indonesia. And I offer the floor to you, and there will be you can present for about 10 to maximum 15 minutes. The floor is yours now.
Thank you, Ms. Amalia. Good morning, good afternoon, or good evening, everyone, depends on wherever you are. We'd like to present our paper titled, Can we utilize nighttime light or NCL data to measure gross domestic regional product or GDRP? Case study of Indonesia using panel data with random effect. This paper was written by Agung Andio Jaya, myself, RR Nefriana, and Riana Rizka, also our organizer, Mrs. Titikanti Lestari. We are from BPS Statistik Indonesia, and on this chance,
hello.
Agung will present. As we know, as statistician, GDRP is one of the widely used macroeconomic indicators to measure socioeconomic development. However, it requires some data availability on the national level to the smallest administrative area level. So the challenge is, the smaller the administrative level, the more complex and difficult the effort to obtain the data. And it's caused by several points. The first one is the low response rate for household and business respondent. And in BPS, from years to years, we always see that the problem of the low response rate for household and business always appear in our performance reports. And the second one is the difficulty to elicit administrative data. Based on BPS transformation program, we want to use administrative data as the primary source of data for producing statistics. However, it's not that easy. For example, with the statistical business register in Statistics Indonesia perspective, we've pursued taxation office for years to get the taxation data so that we can produce our statistic. However, to some regulation that protect individuality, we cannot get the data that's needed. For example, the output and revenue that's very important to produce GDRP, GDP, and other indicators. To fulfill this gap, the national account in BPS Statistik Indonesia conduct some ad hoc surveys. However, due to the non-availability of the subject matter areas, it's very burdensome and arduous. Also, we only use the purposive sampling, so the quality is not as maximum as we want. In this pandemic situation, it's become worse. let alone for the ad hoc surveys, the essential surveys like the continuation of population census for long form, we have to cancel it. So we think that we already know some success story of the use of big data, such as the use of mobile positioning data for the tourism statistic in Statistic Indonesia, also the use of the remote sensing for agricultural statistic in some countries like in America. And we think that why don't we use the nighttime lag or NTL data to be utilized as an alternative data in estimating the amount of GDRP and its change. This is reasonable because based on some studies, for example, in 2012, Henderson, Storgard, and Weil showed that they fruitfully utilized observed night light as an indicator of income across countries and supranational regions. In 2019, Prakash, Sukla, Bhaumik, and Bayer found that net light data correlate robustly with GDP and other critical macroeconomic indicators. And just recently, in 2020, Adhikari and Dital, by exploiting nighttime lights captured by the US Air Force satellites combined with fiscal, political, and administrative decentralization database, they revealed that decentralization hindered regional convergence between first and second subnational regions within the country. Hence, we can see that nighttime or satellite imagery data is actually potential to capture some insight regarding the macroeconomic indicator. And we have done a research regarding this, and Mas Agung will continue in detail.
Thank you for your brief introduction, Efri. From this point onwards, I'm explaining about our studies method and the result we have obtained. The data analyzed in this study...
Still muted, I think, Mas Agung.
Oh yeah, sorry. Okay, thank you for your brief introduction, Efri. From this point onwards, I'm explaining about our studies method on the result we have obtained. The data analyzed in the study consists of 33 provinces in Indonesia with quarterly periods starting from the first quarter of 2018 to the fourth quarter of 2020, in which the economic data is represented by GDRP at constant price by province. That's sourced from BPS Statistik Indonesia. Then for the nighttime light satellite data, employ average day-night band values of monthly cloud-free DNB composite peers that source from EOG data. Maybe you can find it in the website. And to obtain the spatial data for each province in Indonesia, we use Indonesian geometric data in the form of global administrative unit layers, the first level administrative units that source from UNFAO. And then according to Hill et al., when the panel data we have consisting variation in values and trends that can also be observed on each province GDRP data, we can employ the panel regression model with random effect. And this model is the most suitable model to investigate the relationship in the data. The random effect model between nightlight data and GDRP can be expressed in the equation as seen on the slide, the previous slide. And then apart from the investigation of the NTL and GDRP model, this paper is also exploring the relationship between NTL data and GDRP before and during the pandemic. And to achieve this objection, we generate a binary dummy variable in the model to mark the quarter before and after the pandemic. This dummy variable marks the period before pandemic and after pandemic. In this slide, from the analysis process, we got three interesting findings. The first finding, we get an optimistic estimator of nighttime light data and statistical significance in the model. This result indicate that NTL can statistically be used to estimate changes in GDRP. A positive estimator value means that when there is an increase in light intensity, it will increase in GDRP and vice versa. This result confirms the previous finding by Henderson et al. That stated NTL and GDRP have positive relationship. Second finding, although the p-value of the dummy pandemic variable is not statistically significant, the negative value of the estimator can be a sign for us that the GDRP value during the pandemic tends to be lower than before the pandemic. This situation confirms that there has been a decline in economic growth caused by the COVID-19 pandemic that hit Indonesia throughout 2020. The third finding, which is shown from the value of the estimator of the interaction result of the log NTL and dummy pandemic variables, that confirms the second finding. The estimator of the log NTL and dummy pandemic variables is negative 0.01, which means that the relationship between nightlight growth and GDP growth during the pandemic was 10 percentage points lower than before the pandemic. Next slide. Show us the two figures. The left figure in this slide presents the value of real GDRP, while figure 3 shows, the right figure shows the predicted value of GDRP calculated based on the model. By comparing these two figures, we can see that the GDRP values in some areas have similar movement with the observed GDRP values, such as West Sumatra, Riau, Jambi, etc. As for other provinces, the predicted value of GDRP generated by the model doesn't reveal a promising result. And the other interesting result, as we can see in the next slide, is also obtained by our studies. In this result, the model generated the data during the pandemic during 2020. We can see that the overall model is not significant and the adjusted R-square is really small. With this result, the pandemic model presents NTL is not really good to be used as a proxy in measuring GDRP. So we think that's all for the result of our study. Nefri?
Yeah. In conclusion, we can say that NCL variable is statistically significant to explain variation in the value of GDRP. However, model shows relationship between NCL and GDRP during pandemic is not significant. The result might occur, based on our opinion, since Indonesia economy structure is dominated by informal sector rather than the formal sector. And in the future, it is necessary to consider other data to control variable in the model. That's from us. Thank you.
Thank you very much, Nefriana, and also for further presentation. I think the nighttime light data is actually promising to be used, but based on the findings of this paper, that the use of NTL data is more promising during non-pandemic era. So I think this is because of the behavior of the human during the pandemic era is a bit changes, and I agree with you that probably because of Indonesia is more dominated by informal sectors, then that will be one factor affect why the NTL data is not really significant enough to predict the economic activity during COVID-19 pandemic. Again, the future research is needed. I would like to say thank you very much for all the presenters. And now we will have a discussion from Gemma. Gemma is actually now working for Australian Bureau of Statistics, and we would like to hear from you, Gemma. So what is your insights and your perspectives on the use of big data to predict the economic activity during the COVID-19 pandemic? Especially, we would like to highlight more on the COVID-19 pandemic because this is very different. We call it unprecedented situation. Unprecedented situation meaning that we also need to use unprecedented data. So again, I would like to offer the floor to you, Gemma.
Wonderful. Thank you very much, Bu Amelia. And I'd like to open by saying, I'm not quite sure if it's Selamat Datang, Selamat Malam. I'm not sure what time it is there in Jakarta where you are. I'd also like to send a very warm swadika to all my colleagues in Bangkok, and a warm welcome to everybody around the world who's listening into this presentation. Three very good presentations on the use of what we're all calling as big data or non-traditional data sources, and as you say, for very unprecedented times. I have prepared a few comments, so I'll just share my screen and bring up a few comments that I have prepared here for this evening. So for those of you listening in this evening, this is a session on the use of big data to predict economic activity. And yes, as Bill Amelia said, I'm currently at the Australian Bureau of Statistics, but for the last 3 years, I've been working for the United Nations Economic and Social Commission for Asia and the Pacific, and very impressed by BPS Indonesia's uptake of not only non-traditional or big data sources, but also the research that they're undertaking on how do we use these big data sources. ESCAP, the United Nations Economic and Social Commission for Asia Pacific, have just undertaken some desktop research looking at the use of big data by official stats officers. And we've undertaken this in 3 different areas: the use of big data for economic statistics, the use of big data for social and demographic statistics, and the use of big data for agricultural and environment statistics. And I've just put on there a screenshot on the right-hand side of this slide, which is the brief around big data for economic statistics. And as we undertook this research, we provided country examples of the use of online price data, scanner data, mobile phone data, Earth observations, financial transactions data, and smart meter data. So I was very excited to see tonight that we have here some examples of the use of nighttime light data, particularly to predict during the COVID-19 pandemic. And this paper highlighted different uses like price indices, tourism, poverty estimates, economic statistics during COVID-19, and to monitor public sentiment. And I really think Indonesia's these three papers that are presented tonight are really a welcome addition to this research that was published in March this year. So as we already know, we have these 3 excellent presentations by the speakers here tonight. All 3 have come from Indonesia, and I really think this is great to have, to be speaking with you here tonight and showcasing what BPS Indonesia really is leading the way on. I'd like to frame my comments around this very familiar framework that the statistical community use, which is called the Generic Statistical Business Process Management Model. It's a very long title, but this is a really important tool for describing how statistics production in a very general and process-oriented way. And so it provides a real common basis for the way we work, not only where you work in Indonesia, where I work in Australia, but where we as an Asia Pacific region and globally work. And it's a way of describing what it is we do in this fairly common way. And it's a business model, not for business statistics, but for the business of statistics. And I'd like to frame my comments using this framework. So in terms of the first paper, I'm going to use, I won't follow the order of the 3 speakers, but the first paper I'd like to highlight is the one around can we use nighttime light data to measure gross domestic regional product. And this here is an example of where we've used one big data source, nighttime light luminous intensities, to try and produce 2 different indicators, a level and a movement indicator of gross regional domestic product. And I really liked how it was highlighting the purpose of the paper was to evaluate the suitability of using a new data source for an existing economic indicator. So it not only highlighted where we as national stats officers might be able to change our business process around the collect part of the general statistical business process management model, but also it's highlighting where we can design different indicators. And as you say, Bu Amita, these were really important. They're really important right now during COVID-19, as well as any other disaster or crisis that might come across. Now, this paper really does demonstrate the potential of nighttime light data for gross domestic regional product. It really does highlight, as the authors say, it addresses the data collection challenges associated with producing that indicator and the respondent burden, the burden on the Office of the National Stats Office to produce it. However, the findings are not conclusive, and I really congratulate the authors for highlighting that. It's showing that the use of nighttime light data to measure gross domestic regional product was not okay during the pandemic window, which was studied, which was a finding inconsistent with the finding of the Netherlands study. And I really think this is important for the authors to highlight this and for us as the audience to find that. I also particularly like this paper, looking at the right-hand side. I really like this paper too, because not only did they use nighttime light data, but they also use geospatial data. They use remote sense data set. And they've really showcased here also the opportunity to bring together statistical data and geospatial data. And this again is another innovation and another direction that many national stats officers are taking to integrate geospatial and statistical data for the production of official statistics. It's an extremely well-written paper. The purpose and exposition is very clear. It's supported by literature, and it offers some really great insights for others to experiment with these big data sources for gross domestic regional product. The second paper also used mobile, or the second paper now turned, as you just said, Bill Miller, was to use mobile positioning data to measure growth. So the first paper looked at nighttime lights, the second paper looked at mobile positioning data. And here we've used three different types of data: call detail record data, signaling data, and internet broadband activity data of subscribers, also to produce an indicator of gross regional domestic product. And in this case, it was in constant price, so it was like a level estimate. And here the main purpose was to evaluate the suitability of that new data source. So again, it was highlighting where might we be able to make some innovation and modernize what we collect in order to develop a more timely measure of gross regional domestic product. And again, the authors find the real potential for using this mobile positioning data, to measure gross domestic regional product, as well as to detect the dynamics of regional development. But again, the authors really have been fantastic in acknowledging that more is needed. The findings are a start. They've only gone to a 5% sample, and they've only looked at 2 quarters. So really, this is a piece of research that's showing the potential, and it's showing that the potential of the mobile positioning data for gross domestic regional product. Again, extremely well written paper, purpose is very clear, it's supported by literature search, and again, it offers inspiration for others to experiment with these big data sources for that regional product. Now, the third paper is about measuring the economics of a pandemic. And here the big data source, they've actually used 2 big data sources, as we heard, people mobility data, as well as nighttime light data. And they're trying to also measure gross regional domestic product. So all 3 of these papers are exploring different approaches to measure gross regional domestic product. The first one was using the nighttime light data, the second one, the mobile phone data, and this third one was people mobility data, as well as nighttime light data. And here, though, the purpose was a bit different to the other 2 papers. The first 2 papers were basically saying, can I substitute, or can I use nighttime light data or mobile positioning data to measure gross regional domestic product, to reduce the costs of collecting such data, or to reduce the load on respondents, and change the collect part of my statistical business process. Whereas this paper was evaluating the suitability of this data, the people mobility data and nighttime light data, as a proxy for gross regional domestic product, particularly during times of a shock, such as a pandemic, or for other shocks that might happen to our economy, such as disasters that I'm very aware happen a lot in Asia Pacific region. Now, again, this paper also shows great potential for using both those two data sources to give a proxy. And I think this was giving a proxy for the impact of the stay at home or the work at home restrictions that were put in place in Indonesia and many other parts of the region and globally. So really this people mobility data had the potential to really give a proxy for the impact of stay or work at home restrictions on gross domestic regional product. The findings I did find the findings rather complex, however. It evaluates this mobile database proxy and it compares it to a nighttime light estimate of gross domestic regional product. And I wasn't quite sure why the authors didn't use the official gross domestic regional product estimates, why they felt they needed to estimate both the mobility data and the GDP to do this comparison. It does explain that more timely economic indicators are important during a pandemic, but it doesn't really give me an understanding of whether this mobile phone mobility data, is more timely for the production of that proxy. So I think this paper would benefit from a little bit more justification as to the policy relevance. Like, is this mobility data more timely than normal? Is it saving costs? Is the nighttime light really necessarily? And I felt I needed a bit more justification for using the nighttime light data. Also bearing in mind that the previous author's paper found that nighttime light data is not a good proxy for GRDP during a pandemic. So I think it's really important to be clear on whether the findings of the really good findings of using mobility data is influenced because we've used nighttime light data. It might be better just to compare to the official GRDP. So I think the paper really shows great potential for using people mobility data. I think it could be a little bit clearer, some of the technical detail could be clearer, but I think as this paper complements the other two papers extremely well. So I'd like to thank you there, Terima kasih, Kapkun Ka, to all my friends there in Thailand, and it's been a great pleasure to be part of this session at the ISI and as part of the International Association of Official Stats. Very much back to you. Thank you very much, Bu Amelia.
Thank you very much for the comments and also your insights, Gemma. I think your notes are very important to all of us, and we agree. All of us agree already, Gemma, that these three papers are extremely outstanding because it explores a lot regarding to the potential of using big data to predict the economic activity represented by GRDP of Indonesia provinces. So I think this could be one of one of the data that we can use, especially for policy making process during the COVID-19 pandemic, because this could be one of a real-time analysis and real-time factual finding, real-time facts that can be used for the policymakers to really anticipate the situation. We don't need to wait until the official statistics of GDP data is released until 3 months later, but we can anticipate it in more real time to really have a very, anticipative policy. And also we can use this one to prove the policymakers that the estimation and also the real GDP is not really far difference from the projection and also from the real data of the GDP. I would like to say thank you very much, especially to my friend organizer, Ibu Titi Kanti Lestari, for organizing this session. And also I would like to say thank you so much to all presenters and the authors of the papers. I would like to say Sylvia Arini and Rendra, Hani Wulandari and Amanda, Agung and Friana. And also I would like to say special thanks to you, Gemma Van Halderan, for the insightful comments and perspectives on your thoughts. And with that, I would like to end the session. And again, I also would like to say thank you to all participants because there is no question and answer session for this one. And hope if you have a question or some comments, you can reach the authors straight away. You can reach the authors and the presenters from email address, or you can ask from the chat room to you can reach the presenters. And again, stay safe and stay healthy during this difficult time. We hope that this pandemic can end soon so we can go back to normal and we can build the world better than before. Thank you and have a very good afternoon. Bye-bye.
Yeah,